We saw how to solve equations, two linear equations using substitution and elimination method. So this will be the third method solving two linear equations in two unknowns, known as Cramer's rule or method of determination. So in order for us to use Cramer's rule, we need to first find determinants. We call expression a1, b1, a2, b2 the determinant of second order, and in order for us to solve that, we multiply entries in the principal diagonal. So that's a1 times b2, subtract, always subtract, a2 times b1. So determinant of this is a1 times b2 minus a2 times b1. The numbers a1, a2 are called elements of the first column, and b1, b2 are elements of the second column. a1, b1 are elements in the first row, and a2, b2 are elements in the second row. As I mentioned earlier, a1 and b2 are elements of the first principal diagonal, and a2 and b1 are elements in the secondary diagonal. Now, in order for us to use Cramer's rule for 2 by 2 equations, two unknowns, we will end up finding three different determinants. The first determinant, known as coefficients determinant, that is, we write this by getting numbers in front of variables. So 1, 2, that's my first row, 1, 2, 2, 1. So my second row is 2, 1. And now finding determinant of this will be multiplying principal diagonal. So 1 times 1, which will give us 1, subtract 2 times 2, which will give us 4. 1 subtract 4 give us -3. So the first determinant out of 3 is just getting coefficients from the equations in front of the variables and then finding determinant of that. Then in the second step, what we do here is now from this original one, we take away the first column. We replace the first column with other side of the equal sign numbers. So 11 and 7. So same numbers, first column gets replaced with 11, 7. So 1, 2 got replaced with 11, 7. So that is numerator of x basically. Because we are replacing x column, numerator of x will be 11, 7. That's coming from here. And the second column remains same, that is 2, 1. Now finding determinant of this will be again multiply principal diagonal. So that is 11 times 1, subtract, multiply the other diagonal, which is 7 times 2. So we get 11 subtract 14, which will be -3. Similarly, we can find numerator of y. So we go back to the original determinant, and what we do now here is we replace the second column. We replace the second column with 11, 7. So second column will be 11, 7. The first column 1, 2 will remain same. So we're replacing y column. And that's why by solving this, we will get numerator for y. So that will be 1 times 7 subtract 2 times 11. So that is 7 subtract 22 giving us -15. So now we got denominator from the first step, numerator of x from the second step, and numerator of y from the third step. So our solution now will be x equals -3 divided by -3 giving us 1, and y will be then -15 divided by -3 giving us 5. Now to check these solutions, if 1 and 5 works, we'll go back to the original equation. If we substitute 1 for x, 5 for y, we get 1 plus 10, which will be 11. And then again 1 for x, 5 for y, 1 times 2 will be 2, plus 5 will give us 7. Let's see another example. Now for another example here, again we will need to first find out what will be the value of the denominator. So I'll say something like this. The denominator is, now the numbers here, this one's from the previous example. In this example, it will be 5, 3, 3, 2. So this will be 5, 3 as the first row, 5, 3, and then the second row is 3, 2. So then the determinant will be 5 times 2, which will be 10. 5 times 2, which will be 10. Okay, 10. 5 times 2, so 5 times 2 will be 10. Subtract 3 times 3, which will be 9. So the denominator will be 1. Okay. Now to find numerator for x, the numerator x will be in this same denominator, in this same matrix. What we will do here is to find the determinant, we will replace the first column here, which is 5, 3, the x column, with negative 7, negative 4. The numbers without variables, negative 7 here, negative 4 here. Now to find determinant, we multiply entries in the principal diagonal. So negative 7 times 2 will give us negative 14, and negative 4 times 3 is negative 12. So subtract negative 12 will give us negative 14 plus 12. Negative 14 plus 12 will be negative 2. And very similar way, we can find numerator for the y then. Numerator for y, what we will end up doing is then, numerator for y, we will replace the first column will remain same. The x column does not change. It has to be 5 and 3. So this will be 5 and then this will be 3. And the y column, because we want numerator for y, the y column will be replaced with entries on the other side of the equal sign. So negative 7 and negative 4. So this will be then negative 7 and this will be negative 4. So now simplifying this, we multiply 5 times negative 4, which will give us negative 20, and then these two, 3 times negative 7 will give us negative 21. So again, we multiply principal diagonal, 5 times negative 4 gives us negative 20, subtract another diagonal, so 3 times negative 7 will be negative 21, negative 20 plus 21, which will be 1. Okay, so then now the solution will be x will be then negative 2 divided by 1, which will be negative 2, and y will be then 1 divided by 1, which will be positive 1. So the solution to this system will be negative 2, comma 1. Now let's put negative 2 there and 1 there in the original equation. Negative 2 here will give us negative 10 plus 3 times 1 will be 3. Negative 10 plus 3 will be negative 7. For the second one now, again we will put x equals negative 2, y equals 1. So negative 2 times 3 will be negative 6. Y is 1. So 2 times 1 is 2. Negative 6 plus 2 will give us negative 4. So that solution is correct. It works for both. So we've seen 3 different ways of solving two linear equations with 2 unknowns. Method of substitution, method of elimination, and this is the third one known as Cramer's rule or method of determination. You can use any of them. Doesn't matter. You can use substitution, elimination, or Cramer's rule.